Hello everyone. Okay, our topic that we chose for our project is optimization. So optimization is basically just the application of derivatives. Given situations, you must optimize the problems, meaning you have to find maximums or minimums according to the specifics of the question. Often, optimization involves formulas such as distance, volume, area, and the Pythagorean theorem. These are just some of the formulas that you can use, but either way, often you end up with multiple variables. However, you can only solve a problem with two variables, one with you, so you can set it equal to 0 and all this stuff that we'll go through. Therefore, you must be able to manipulate the equations. So let's start with an example problem. We'll start with a really basic one. Let's go with which points on the graph y equals 4 minus x squared are closest to the point 0, 2. Okay, so what it's asking us to do is find sort of the distance between a point on the graph to the point 0, 2, and we have to figure out which the shortest distance. So let's look at the graph of y equals 4 minus x squared first. Okay, so we know that's an upside down parabola. And we know that we are looking from the distance from, let's say this is 0, 2. So that's the point we're trying to find. We're trying to find which point on the parabola has the closest or the smallest distance between the 2 points. So we know we're going to have to use the distance equation then. And the distance equation is d equals the square root of the quantity x minus x2 squared plus y1 minus y2 squared. So if we know that the one point we're trying to get to is 0, 2, we can then plug in some of the points. So we know that x2 will be 0, so we can simplify that too, so we'll end up with just x squared, so we'll end up with x squared underneath here, plus y minus, what's the y point, 2, and that quantity squared. Okay, so now this is what we were talking about before, how there are 3 variables, but we can only solve it with 2. So if we look at this y right here from the beginning of the problem, we know that y is equal to 4 minus x squared. So if we can substitute that in for y, we will only be left with 2 variables, d and x. So let's go ahead and do that. We'll be left with d equals the square root of x squared plus the quantity 4 minus x squared minus 2, that quantity squared. So our final equation then is going to be d equals x squared plus 2 minus x squared. Okay, so that equation is going to be the distance from any 2 points. Now this is where the application of derivatives comes in, because we can then take the derivative of that function and find the maxes and mins of that function. And what we're looking for are the points that are closest to 0, 2. So that'll be the mins of the function. So what we do is take the derivative of that function. Now you can just plug that into a calculator, and you end up with the derivative being x times 2x squared minus 3 all over the square root of x to the 4th minus 3x squared plus 4. So now we set that equal to 0. This is the easy part. We set that equal to 0, and we solve for x. And plug that into your calculator with the solve button. So solve x times 2x squared minus 3 over the square root of x to the 4th minus 3x squared plus 4 equals zeros, comma x, parenthesis, and the parentheses, and hit enter. You'll find that x is equal to negative square root of 6 over 2, 0, and positive square root of 6 over 2. Okay, so then the other point we need to think about is whether or not this exists everywhere, because we also have to include where it does not exist in our points when we're trying to find the minimums. But this function does indeed exist everywhere, so we do not have to worry about that. So then here comes the easy part. All we have to do is put this into a table and find which ones have the smallest d value, or distance between the 2 points. So we know that one value of x is negative square root of 6 over 2, another one is 0, and another one is positive square root of 6 over 2. So then what you need to do next is just plug in x in the d of x, which is this equation up here. And we know that we can do this because we have the x values and we can solve for d. So we plug in negative square root of 6 over 2 and all the rest of the values, and you end up with square root of 7 over 2, 0, 2, and square root of 7 over 2. And you end up with these two values being the minimums. So when it asks which points are the closest to 0, 2, the 2 points are going to be negative square root of 6 over 2, square root of 7 over 2, and square root of 6 over 2, square root of 7 over 2. So the next problem that we're going to optimize is one that deals with volume. Alright, so the first thing that we need to look at is what exactly we're optimizing. And so in this case, it's the trough's volume. So to begin with, we know that we're eventually going to need the volume equation. So volume equals your base times your height. And so because our volume is going to be base times height, we first need to figure out what our height and base are. So we know that our height is equal to 20, and we know that the base of our shape is a trapezoid. And so the area of a trapezoid is base 1 plus base 2 over 2 times the height of the trapezoid. So once we have that formula, we then need to figure out how to get this equation down to two variables. And so to do that, we need to go ahead and look at the trapezoid, okay? So, what do we know about the trapezoid? We know that our base 1 is equal to 1. What we don't know, however, is what base 2 is, and we also don't know what the height is. So, we need to look at this and to figure out how to get these in terms of theta. Alright, so let's take a look at base 2 first of all. Okay, so if we know that base 1 is 1, then we know that this portion here is going to be 1 as well. That means we then have to figure out what this portion is and what this portion is. Okay, so base 2 can then be given as 1 plus 2x. But how do we get theta in terms of x? Okay, so let's look at the triangle itself. If this is theta, and this is 1, and this is x, how do we get x in terms of theta? Okay, so we know that if we take the sine of theta, that gives us opposite over hypotenuse, which is x over 1. So, knowing this, we could then take this base 2 and make it read 1 plus 2 times the sine of theta. There, one of our variables is solved as to 1. Okay? So now, we have to look at the height. How do we find out what the height is? Okay? Height is the cosine of theta, which is adjacent over hypotenuse. So, now we have the height, which is cosine of theta. So now that we have our variables, we're going to take them and insert them back into our volume equation. So volume equals 20 times base 1, which is 1, plus base 2, which is 1 plus 2 sine of theta over 2 times cosine of theta, which is our new height. So now that we have this formula, we are going to simplify it. So volume equals 20 times 1 plus the sine of theta times cosine of theta. Alright, now that we have our volume formula, we need to figure out the maximum of this formula. And to do that, we are going to take the derivative. And you just plug this in your calculator. That would probably be the easiest way to do that. So once you have the derivative, you're going to set that equal to 0 and solve for theta. So when you do that, your answer is going to be theta equals pi over 6. So we have one answer to the problem. However, we must include what our limits of the problem are. And since it is radians, we know that our limits are going to have to be 0 and 2 pi. So when we create our table to determine if that really is the maximum, we're going to plug in these different values. So we have theta, and then we're going to have b of theta. Okay? So we have 0, pi over 6, and 2 pi. Alright? So we're going to take these values of theta then, and we're going to plug them back into our original volume equation. Okay? And so for 0, that formula is 20. For pi over 6, it's 15 square root of 3. And for 2 pi, it's 20. And so we can determine then from this that our maximum volume will be given by pi over 6. Alright? And so it's pretty easy. Again, it's just making sure that you have your equations set out, making sure you eliminate more than 3 variables that you have so that you only have what you're trying to solve for and one other variable, and optimizing that problem. And that's it.